We introduced the concept of natural language processing, and in particular, the bag of words model for representing and quantifying text for later analysis. In this lecture, we expand on those topics, including some additional preprocessing and text representation methods. So in this lecture, we learn about how to implement several preprocessing techniques like stemming, stop words, and minimum counts. And also we understand the concept of feature vectors in natural language processing. And at the end, we get familiar what we mean by Tfidf. Let's see. In previous video, we learned about how we can read the text file, how we can lowercase or uppercase everything, how we can split that text into single words and remove trailing white spaces. But there are a few more than that that could be very powerful. Let's go back to Alice in Wonderland example from previous lecture, but this time we're going to add a few more books for comparison. We read all these 7 books text files, and then we do some text preprocessing, like taking care of stop words and stemming. For this one, we are going to use an external Python package, which is called NLTK. It has a ton of really interesting stuff that goes way beyond the scope of this lecture. But for our purposes, though, we are going to use stemming capabilities of this package. Going back to our previous example, Alice in Wonderland, now we want to work on different other textbooks. Here we have these textbooks, Pride and Prejudice, and all of these books. And we want to see how we can process all these texts. In this part, we're going to read all these textbooks and we put them in a dictionary. And then based on their name, we separate these parts like Alice, Pride, and we're assigning all these names as the key. So here we split up based on this backslash, the last backslash, as you can see by this index, and then this dot here, just to remove the extension and separate these names, and we assign these as the key. So here we print books keys. You can see that we have this dictionary with these keys and then their textbook. Then we have a function preprocess. By passing each book, we want to process the text. So we lowercase everything, and then we strip out white space, and then we count all the words through this function. After doing this, I know that you're familiar with all of these. We worked through all this, and then we count the words for each one of these. We are using default, if you remember that default dictionary, to have them and put all these values there. Then by going through each book by this loop, we are calling preprocess function, and we pass the textbook to this function, and we count the words. So here we want to print the result, and as you can see here, we have Alice with these words, and the most common word appeared 1,777 times. For Pride, this, for Frank, this. So we got this information. Yeah, it works. Now, as you remember, we talked about stop words. And here we want to have a default text for our stop words. We are reading all these stop words from this stopwords.txt. I put this text file for you on ELC so you can practice with all of this. And also remember, please pause the video and write them and do some experiments on each one of them and see how it works before moving forward to next steps. All right, so we read this stop word text file, and as you can see, we print just 5 of them, and you see some of these stop words, what they are. Then we have another version of preprocessed function just to include stop word processing by going through all of them and comparing these with stop words and removing them from our count. Then again, we print out all those information and you can see how it works. All right, so there is something wrong with this because some of them got worse and some you can see we don't see any more changes. So what we do, we have a problem with the words that are just blank string like this. So we try to ignore all of this. We rewrite our function, we call it preprocessed version 3, and then we try just to remove and not count the words that are less than 3 characters. That's how we can do and remove them. Then again, we print out our information, and as you can see, it improved. Yeah. Let's see, what about this one? We want to add a check on punctuation like this, a comma, exclamation mark, a point, a colon, and then all these. So we are trying to see if there are any of these characters in our text, we want to exclude them in our preprocessed version 4 function. And then again, we print out our result, and you can see that we've improved it a lot. Next part is about stemming, how it works. There is another thing, another package, NLTK, that has a very interesting stuff in function for stemming that we want to use this package. So in function preprocessed version 5, you can see that we are just gonna include this part and see how it works. By going through all of these and using this stem function, we can see that it improved so much. And we have a better result for counting all the words in our textbook. Now, we want to remove any word that appears only once in our text. So it helps us to get more and more information, to extract more information from each textbook. So here, how we do that is this part, that if that keyword in that dictionary for the words has appeared only once, we're gonna remove that from our numbers. So here again, we print the result and you can see how much it's different from before by doing all these processes. So now there is a comparison between all of them from our first result to the last one that we had the preprocessed function version 6. And as you can see how it changed from this book, we had this number of words, but it reduced to this number. And also for this, like Alice in Wonderland, we had about almost 3,000 words, and now we have 1,400 words. Pride and Prejudice, we had about 5,000, almost 6,000 words, but it reduced to 3,000 in almost, also for other books. That's how we can work on textbooks, on text, and just extract some nonsense words and include some more important words and just clear that and get more information. Please pause the video and work on each one of these functions yourself. Now we want to learn about Tfidf that can do wonders. But before we start talking about Tfidf, I want to just say that it was introduced in 1972 by Karen Spark Jones. All right, before we start our discussion about Tfidf, let me explain bag of words in brief and remind you about this just to make it easier to understand why Tfidf was introduced. What is bag of words? That's a representation of text that carries information on the occurrence of the words within a document. I'm going to put it in simpler words. It's like we have an empty bag and we have a collection of the vocabulary of the documents. We put the words into the bag one by one. What do we get? A bag full of words. Now let's dive into it. TF stands for term frequency and IDF stands for inverse document frequency. And this is the formula we're going to use. TF-IDF, it's equal to term frequency over document frequency. In other words, we can say that TF-IDF is equal to term frequency times inverse document frequency. Actually, it gives us a measure of how important and unique a word is for this document. We've already learned how to compute term frequency. That's our bag of words. Just count how many times a word appears in a document. And then we normalize it by the total number of words in a document. So we can say that TF is equal to number of repetitions of word in a document over number of words in a document. IDF or inverse document frequency is a fraction. The denominator is the number of total documents we are using. Like in our example, we're using 7 books. The denominator is the number of documents that contain the term we're looking at. So this number should always be less than or equal to the denominator. Totally, we can say that IDF is equal to number of documents over number of documents containing the word. Going back to our example, we want to compute TF-IDF for our books. As you can remember, we had 7 textbooks. Now here in this part, we're just gonna convert all the columns to a matrix. The rows are documents that we have 7 rows, and then the columns are count for each word. So by going through this process in loops, we can have this matrix that, as you can see, the shape is the length of keys and then all the words for all the documents. All right, so here what it means, that 12 has appeared, first word has appeared 12 times in our documents, 0, 0, 3, and 0, and so on. Now, for calculating TF-IDF, first, we need to have a matrix for TF-IDF. That's the shape of the keys and then the length of, based on the length, the number of keys and the number of words for our document. So we are going to go through this process, which, if you remember, term frequency is the number of repetitions of a word in a document over the number of words in a document. And then that means here for calculating TF, we have the column over normalizers, which is this one, count matrix, the sum of all these for our document, all those numbers for each document that we have this normalizer. And then what we have is IDF. IDF is the number of documents we have, which is 7, over number of documents that contains that word. So here we have number of documents, and if any document contains a word, that means it's greater than 0, which we calculated this by the length number of columns, which is greater than 0. And then we have our formula for TF-IDF, which is multiplication between TF and IDF. Then after calculating TF-IDF, just we want to visualize it to see how it works, then we can use Matplotlib PyPlot as PLT, and we can just show this TF-IDF here. As you can see for each book, how all the words frequencies are. And this is very compressed, so you can just work with each one of these textbooks to see how it is and what we mean by all of these frequencies. Now that you learned about TF-IDF and how it works, let's see what's the applications of TF-IDF. We can use it for information retrieval, text mining, user modeling, keyword extraction, and also in search engines. Please rewatch all the videos and